How could I miss that thing?
So, OWASP top 10 proactive controls. Hey, my Uber driver took me to Redondo Beach. I'm very sorry. We're going to get started. We're going to do the talk.
Did you give him a good tip?
Jim, we would have mentioned that.
Yeah.
Like a tornado.
And it started and stopped the whole thing.
I just thought I'd keep it open.
I think you got a automatic exposure going. Yeah, it's automatic exposure.
Why is that?
You try to turn that part off. Now when people walk by, it doesn't go up and down. Right now.
Do I need to tap it? It's okay? Okay. Should I go back to the screen? Yeah, I'll check on my other phone.
Oh yeah, OWASP top 10 practical controls. Hi, my name is Jim Manico. Do good things at OWASP. Let's get started. Control number 1, parameterize queries. Look, this talk is a review talk. This is meant for someone who's new at application security, new at secure development. Application security is a big field. And you hear a lot of noise about assessment technology. How do we assess if the application has vulnerabilities or not? Don't get lured into thinking that's application security. That's a piece of the puzzle. But it all comes down to, whatever area of application security you're looking at, it all comes down to one thing, LOC. A line of code that you are writing securely or not. And there's a lot of ways to get to that. A lot of ways to climb the mountain to get to that. Are you writing this line of code securely? And that's really the goal of this project. It's to provide entry-level awareness to developers about secure coding. If we look at a lot of traditional OWASP documentation, ASVS, that's a penetration testing measurement or assessment measurement. The OWASP top 10, that's from a risk perspective. It really focuses on problems in an application. So I've taken a lot of that knowledge and converted it into more positive language. What are the right things we should do to build a secure application? So it's kind of like a developer-centric fork of existing OWASP work. Number 1, and hopefully this is review, let's parameterize our queries. We look at the main risk of SQL injection, and this is a famous cartoon. What's wrong with this cartoon? It's academically wrong. It's intellectually wrong. Hi, this is your son's school, we're having computer trouble. Oh dear, did he break something in a way? Did you really name your son Robert, single quote, semicolon, drop table student, semicolon? Yes, we call him Little Bobby Tables. Well, we've lost this year's student rec, hope you're happy, and I hope you've learned to sanitize your inputs. What's wrong with this cartoon? Very famous in the security industry among AppSec geeks. What's wrong with this is, you don't ever worry about sanitizing your inputs as a primary defense to stop SQL injection. Here's why. Is this a legal email address, by the way? Is it? Is this a legal email address per the RFC email standard, per what Gmail and other providers support for email? The answer is yes. And this is a SQL injection attack. Single quote will end a string, dash dash is a comment in SQL. So if I have a feature like edit email, this is a similar code that we'll see, or code that we'll see to conduct this. Update the user table, set email equals single quote, that's hard coded from the developer, new email, what the user typed in, single quote, where ID is some ID of that user. Now the email that the user puts in is this legal email address, and you have some sanitation layer or input validation layer trying to prove it's correct. Well, you can't sanitize this. That is correct. That's a good email address that you should be supporting. And look, update users, set email, and there's the email address I'm dumping in. What does your SQL interpreter do with that? It comments that out. That's what hits your backend database. Update user, set email is double dash. What is that going to do to your day? What do you think? It's going to ruin your day because every email address in your system just got wiped out. And from a legal email address that you sanitized properly or you validated properly, you need to do this, query parameterization. This is PHP, PDO, the most common language on the web. Yes, you can build secure PHP apps. A lot of people mock PHP inappropriately because it doesn't matter what language you're using. It matters what developer you have writing code. That's the statistical differentiating factor when it comes to secure software. It is not the language, it is the programmer. So are you going to use this technique or not? It's trivial. We have placeholders in the query and binding statements to bind untrusted data that users typed in. We bind those into placeholders. Now how does this work? At the database level, when you parameterize your queries like this, you're actually sending data into the database in two passes, two virtual passes. Pass one is the bound query with these placeholders. The database then builds a query plan, compiles your query, it has the tree of the exploration of the database all dialed in, and then the inputs get sent into that existing query plan. Hey now, your query plan has been built already. It's compiled. There's no way input can change that plan. If you do this at the query level and then send an attack query in, you got injection. But if we use compiling, if we use this methodology, query parameterization, and it's trivial, something you can teach a developer in a few minutes. Injection goes away because of how the database orders the operation of this query, the compiling of this query. We have the same thing in .NET. We have the same thing in Java, OQL. Those of you in the world of Hadoop. Hadoop is great for putting data in, but all these NoSQL databases are horrible at pulling data out. So you're going to end up going to OQL against a NoSQL database, which is just SQL. You have to parameterize those queries as well. Even Perl. Anybody here still programming in Perl? I sure hope not. It was written by a really insane linguist. A lot of people love it for language processing. It doesn't matter about the language. It matters if you use the right technique. We have question mark for placeholders. We bind that in. The query gets precompiled. Injection becomes impossible. That's control number one every developer must master. Look, we're in 2015. A lot of big companies have SQL injection dealt with pretty well by now. If you're in a company that has not dealt with AppSec, if you're just approaching secure coding, I say don't be lured into high-level black boxes that try to stop this. I say just go fix your code. Go through your whole company, fix all the queries, make them parameterized. It's a relatively easy fix, and you fix the root cause, and you also test your organization's ability to conduct secure coding and remediate insecure code. Number two, you want to encode data, escape it, before you put it in a parser. The classic one I like to talk about is cross-site scripting. So encoding, control number two as a developer to write secure apps. Here's an example of cross-site scripting. Look at the bottom here. So I have a comment, like on some news site called JNN, Jim's News Network, right? So in JNN made-up site, if there's a comment, and I comment this inside of a news article when I log in, Then when you go and read the article, what does this script do when you see this in the comments? What does this comment do? You up front. What does this do? Document.body inner HTML. What's that?
It would render a page. It says go OWASP.
Go OWASP with the blink tag. Yeah. It's going to overwrite the whole page. It's called virtual defacement. Anybody who reads that article where I put that comment in, that JavaScript executes, I end up defacing virtually the page while that comment's active. Now that's fun. That's not a super damaging attack in most situations. Look at the above here though. Imagine you're an administrator and I add a comment into my profile description. Then I go email the admin and say, hey admin, there's something wrong with my profile for some reason. What does the admin do? He logs in. If he's probably already logged in to read the message and he hits my profile to look at it. The admin hits my profile, this code executes, we grab document.cookie. Why is that important? It's the admin session token, session ID. I add that to a URL, that's a site that I control, then I load an image with that source, and all of a sudden the admin invisibly, without even seeing it, I grab his cookie, add it to an image, make a request to my site, and I see his cookie in my log files where I can now hijack his account. Now, you want to use an HTTP only flag on your session cookies. That stops JavaScript from reading it, but it just stops that one kind of attack. It doesn't stop all cross-site scripting. To really stop cross-site scripting, you're going to get different technique. And when you can get evil JavaScript into a site, you can steal the session, do virtual defacement, undermine other cross-site request forgery defenses. You can load scripts from third-party sites. You can steal any data. You can do a keystroke logger. Cats and dogs are living together. It's that kind of problem, Richard. You know what I'm saying? You got it. So here you go. Boom. When your browser sees this character, what is it going to do to this character? What does the browser think of this character in the body of an HTML document? What does it think you're trying to do? So does the browser think of this as code or as display data? It's code. You do not want user display data to be interpreted as code in the browser. Are you ready for the bonus question? For the free trip to Hawaii, the free Mercedes, are you ready?
Sure.
How do we put this on the page so it's not going to be treated as code?
10%.
Boom. Oh, the free trip to Hawaii, I'm fully lying to you. I'm so fully, sorry, I'm not talking about that. Trust, but verify. Right? So ampersand LT semicolon is the encoded less than character. It will be treated like display data and not code to start an HTML tag. So how do you do this in a more standard way? You're going to go write all these encoding functions by scratch yourself? Please don't. Use some library. In the .NET ecosystem, you have the anti-XSS encoding library, really well built. It hasn't been updated so much until it was updated last like late 2014. It's reasonable. You don't need to go elsewhere. And where do you do this encoding? On input when you first get data? No. In the user interface when you're displaying data. The reason is because we're going to have to encode in lots of different contexts. This is a project I work on, the OWASP Java Encoder project. This was used by a lot of companies that needed mammoth scale. A lot of the encoders in Java use string manipulation and they're slow for mammoth scale. So this is using like a thread local and various buffers to very efficiently encode. Now this actually broke in Tomcat, breaks when Tomcat shutting down because Tomcat is a piece of garbage that doesn't know how to handle threads well. So we're in the last update, and we're actively working on it, is what I'm trying to say. January 16th, we're dropping thread local, tweak the performance a bit, but it's going to be a little smoother in the servlet container. You can use the original one, it doesn't hurt, it's super fast because we're using thread locals for memory management, but weak servlet containers don't like that. So we're about to roll out a new release soon, but you can drop 1.11 in now, and it's going to run in production well. When you do output encoding, you need a different function for every context in the document. So we have encode for HTML, encode for JavaScript, encoders for XML, and I have some other slides on this. There's easy routes that are a little less efficient and more difficult routes that are ultimately efficient. So we see some people using this to build their own automatic template escaping system. And these encoders are available in every language. Ruby on Rails has a built-in util library that escapes in 4.0 and above. PHP has several decent encoders. Java and Scala people have access to the project I just showed you, the OWASP Java encoder project. .NET has anti-XSS. Go has a really neat auto-escaping template language. This is great. You just use their template system, and it will recognize what context you're in within the web document and auto-encode in HTML, JavaScript, CSS, or URI encoding very accurately. So this is the future of XSS, where you have frameworks that auto-escape contextually at the user interface for you. And there's an old-school OWASP reform project for legacy encoding, like for Perl and stuff like that. And so there's also other injection issues, LDAP encoding. There's some in the SAPI and anti-XSS. There's command injection encoding. Be careful here, just don't run OS commands through a web app. XML encoding functions for doing XML processing in the browser. And there's Boulder Security has a great encoder reference implementation I ran across recently. So lots of options. Anytime you hit a parser with untrusted data, it's usually encoding in the right context, in the right kind of parser, and these encoding functions are available. They're a little esoteric, but they're needed for secure development. Next, number 3, you want to do input validation on all inputs. This is not great security, it's more good hygiene. When you're doing a regular expression to check if input fits your application semantic, that does not necessarily make it secure. It just says that the data will fit the semantics of your application. It still reduces the attack surface, but a lot of people mistake input validation as being security. We saw the validation of the email address, that still made it dangerous. How about validating comments in CNN? I'm just making, whatever. So CNN, the news is fun, those comments are even more fun. That's where the trolls, that's where a lot of trolls live, it's a lot of fun. But how do you validate a comment? Right, Tony? You need letters, right, Tony? You need lowercase letters, you need spaces, you need punctuation marks. I know you're a nasty hacker, so if you could have any letter, a space, and any punctuation, what could you do? Say it with drama, please.
Say what?
Say it with drama.
All depends on what I'm attacking.
Again, you get all punctuation marks, you get space, and you get letters. Do you need much more to conduct serious attacks?
No, not much.
Yeah, you're in.
Right.
But the comment might be now work for the semantic of the application, but it doesn't make it safe. So there are some specialized cases I want to talk about. If you use like TinyMCE or CK editor or some kind of WYSIWYG editor, that's a component in a web page that when you hit submit, it submits a chunk of HTML. So I can do anything. I can add images to this, bold, highlight, colors, fonts, a bullet point list. Excuse me. So that submits as a chunk of HTML. Why can't we just do encoding anymore? What if you encode HTML? Then you see HTML on page, it breaks the feature. So we have to take arbitrary HTML from a user and make it safe somehow. We want to use a formal HTML sanitizer like that. There's the OWASP HTML sanitizer. It lets you build programmatic policies around what tags it'll accept, and it auto-rejects everything else. This kind of plugin or this kind of tool is available in every language. Ruby on Rails has HTML validation built in. We have the OWASP Java HTML sanitizer, donated from Michael Samuel, one of Google's AppSec leads. We have PHP has the HTML Laud project, Python has Bleach. There's a Kaha from Google. There's plenty of HTML sanitizers out there if you look for them. So, and other specialized validation is like file upload. You have to be careful about file storing it properly and doing access control around it. This specialized validation does come up in other contexts. Next, access control. How am I in time, by the way? What time is this?
2:11.
2:11.
What time do we end? 2:45 or
45. Okay.
Oh, we're going to make this. So next, access control. How do most frameworks and languages do enforcement points for access control? That's the question I'm going to put up there. Let's define what I mean by that. When we look at access control, there's a couple pieces to it when we look at formal access control standards. There's the rule engine, there's the enforcement point, and there's data feeds into that system to make decisions. The key thing as a programmer that we run into is the enforcement point. So when I'm in code, day-to-day writing code, how do most of us add access control to an application in our code today? What do you think? When you're writing an application and you're trying to put some access control right to the code, What do most frameworks encourage us to do in those checks? Somebody.
Validate it.
Role-based. Guess what? When you're using role-based access control in an application and you're hard-coding roles in the app, you know what that is? That's the big suck. And it's not the fault of the developer. Every single framework really leads us down this path, and it's fundamentally wrong. One of the biggest failings of application security, we haven't provided good permission-based access control to developers. So if you want to, so let's just get into it. So access control anti-patterns, hard-coding role checks in code. So look at this. Let's talk about it in the Star Wars context. Yeah, Star Wars. So here I'm building a game. It's a Star Wars game, and the user is trying to wield a lightsaber in their hand. Now, in the Star Wars ecosystem, if a normal person wields a lightsaber, their time, if they start practicing with it, their time to live is like 30 seconds, right? You make a mistake, you hit yourself, and you're dead. So you gotta have the force, dude. You gotta be able to see into the future a little bit to use these weapons successfully. So, if the user is a Jedi, or if they're a Padawan, or if they're a Sith Lord, like Darth Vader, or if they're weird, and we build that out, we get it working, and then the next movie comes out, and it's General Grievous, that cyborg robot. He's not a Jedi, he's not a Sith, he's a specialized general warrior who was almost killed in battle, turned to a cyborg, and then trained by Colonel Sidious to use lightsabers in a robotic fashion to kill Jedis. He's a whole special case. Boom! So that the user's a Jedi killing cyborg. I have to put this in code, maybe 5,000 locations. Every time I have, oh no, now Han Solo can with a lightsaber and open up something, a new role, and it never ends. Every time the application changes, I have to go and change this in code because I've hard-coded my policy right in the page. We have got to get away from this and move to a permission model. Compare it to this, where I have this hard-coded in the app in 5,000 places. If the user is permitted to wield a lightsaber, let him do it. I look up that permission, see if they have entitlements for it, and maybe there's roles in the back-end system, but not for enforcement points. So things like Apache Shiro do this natively, and here's a data contextual way of doing a permission check. We're trying to see if the user's allowed to drive this current Winnebago that they're moving into. So we grab the identity from the request, the Winnebago ID they're operating on, and then I get the rest from the server. If the user permitted to drive Winnebago of that number, let them do it, no problem. And so, if you want, I can show you a data model, what would look like behind the scenes here. The benefit of a permission model is that even though it's a little bit more work up front, the maintenance of it is much easier and even better. You can now do multi-tenancy and shard out your application to 10 different customers and have completely different access control rules for each customer without changing your code. That's the benefit of this. It's a multi-tenant data contextual built in when you go to a permission model. Next, establish authentication and identity controls. Doing login. Now we could just talk about login for hours and just scratch the surface. So I want to hit upon a few points that a lot of people get wrong. A few points that we see a lot of applications getting hacked recently, and big news comes out when this happens, and that's usually password theft. So we saw like LinkedIn, we saw Living Social, we saw Sony a few years ago, we saw eBay recently leak their password database, and in all these cases, it was either in plain text or very weak cryptography, and all of a sudden user passwords are dumped to the whole world. This is a common attack that we've seen a lot of in 2013 and 2014. So let's talk about what you can do as a developer to store your password in the database of your users for authentication in a secure fashion. So even when your database leaks, you're going to have time to fix the problem. We want to make it hard on attackers to crack this. So number one, we never want to use encryption for password storage. Number two, we never want to use hashing for password storage. Hashes are too fast. We want to use a class of cryptographic algorithms called KDFs. What's a KDF? It's a key derivation function. It's just like a hash in that you give it some plain text and it gives you a large piece of ciphertext, a key in this case. The benefit of these algorithms is they can be made slow on purpose. Let me explain this. So number one, don't limit the type of characters in a password. Do you ever go to a bank? Tony, let me ask you a question, Tony. Hey, Tony, let me ask you a question.
Yeah, go ahead.
You ever go to a bank, you set up an account there, you put your money in. You're giving them your hopes and dreams and trusting them to protect you, your family, and your wealth. Are you with me?
Sometimes, yeah.
Sometimes. And you go and set up an account there, right?
Yeah.
and the bank tells you, Tony, we know that you're a security guy, you're giving us a big password, but can you please reduce that banking password down to 8 characters, and don't give us all these funky characters. We only accept these characters, and we don't offer multi-factor yet because we can't afford it. You know, we got big bonuses to pay for our execs, so we'll do multi-factor next year.
Right.
What are they really trying to say to you?
Take it back to the mattress.
Dude, boom. They're telling you they don't care about you as a consumer. They care about their executive bonuses more than you.
Right.
Look, and also it's laws. Barclays, for example, I'm not going to go there. Let's rewind. So don't do that. Let users give you giant passwords with any character, because you want to stop injection by coding, not by limiting input. Now password managers are more effective, and smart users can give you long passwords. Number 2, use Assault. Tony, can I keep picking on you, or should I move on to something else? Tony, let me ask you a question. Tony. I know your password, and I'm going to reveal it. We'll change it soon, right? Mm-hmm. Your password is FluffyBunny1. I'm sorry. That's my password too. What if we have a protection algorithm, that's a common protection algorithm, and apply it to both our passwords? What does the ciphertext look like?
Exactly.
It's the same. So by introducing Assault, when Tony creates his account, we'll build a large random value and stick it in his account. When I build my account, we'll use a random algorithm, make sure it's unique, and stick that on my account. So when I enter my password FluffyBunny1 at registration, I take the salt from my account and then protect it. Tony has a different salt and we protect it. What does that do? It deduplicates the ciphertext. Even though we have the same password, the salt deduplicates that because it's random and unique for every user. So that's the only purpose of Assault, to deduplicate similar identical passwords. In the world of symmetric cryptography and asymmetric, it's called SALT. I'm sorry, it's called an IV, initialization vector. Same thing, deduplicating ciphertext even when the plain text is the same. All right, number 3, we want to make this tough on the attacker. We want to use a slow algorithm on purpose. 3 major choices recommended by cryptographers. PBKDF2, you give it your salt and password, and a work factor. This is how many times it's going to loop the same internal algorithm purposely to slow it down. The NIST standard says to use 1,000 loops in the year 2000, double it every 2 years. We should be about 140,000. Most systems I've built use like 500,000 and makes it configurable so I can increase it over time. And so there's also bcrypt, which is a great go-to choice, and scrypt if you want to also do a memory-hardened defense. More on this is out there, but those are your 3 choices. PBKDF2, bcrypt, or scrypt are the 3 go-to algorithms. Now, if you're a bank, or you're like a Twitter, or you're dealing with a huge amount of logins in one clock cycle. Like if I look at just a slice of your system, and there's like 1 million users logging in concurrently, like on Payday or a video game system, then these slow algorithms break down, and we want to consider a different architecture. This is only for super specialized situations. Just go to those other algorithms for the most part. And HMAC is super fast, and it will it's basically a one-way authenticated hash. And so Facebook recently revealed their password storage system. They have a lot of hardware to play with. They actually do scrypt and then HMAC the scrypt with a private key on the server. I'm going through this fast. Another thing you want to consider is ban common passwords. If your enterprise system of your multi-billion-dollar company accepts this password, that's a problem. It's uppercase, lowercase number, non-alphanumeric, but it's uncommonly common and should be rejected even if it fits your policy. So consider having a ban list of commonly used passwords. Good research on that for US English is at Zato.com. Xato.com has a lot of good research on what commonly used passwords are around for that year and era, and be ready to change it on a regular basis. But this is kind of a moot conversation. You really want to not depend on password storage and passwords and move to freaking multi-factor authentication to stop primarily horizontal brute force attacks without necessitating count lockout. This is Blizzard. This is a World of Warcraft. They offered multi-factor like 10 years ago. If you're going to protect your wizard, your fighter, and your hunter from attack, you may want to protect your multi-billion financial institution from attack as well. Moving on. So other things to consider here is the forgot password workflow when we talk about authentication. So forgot password, what do a lot of sites do? That you type in your email, and then they send you a link, you press on it, and you're good to go. Email is not secure. It's plain text through the net in many contexts, not everywhere, but somewhere. And look, if you look at the FFIEC banking rules, they say even if your online user's email is compromised, you should still be able to protect that account. So you'll notice that most smart banks, they do not use email to communicate to you. They do it through their portal. And if you want to reset your password because you forgot it through a bank, especially Chase and most US banks, they go through this workflow. Like Chase will say, give me your social security number and your credit card number to establish identity. And then they'll send you a text or other multi-factor connection for the next hop. They'll send you a token. In the same session, you must answer it, and then you can change your password. It's not perfection, but it's multi-factor, essentially, even for a system that normally just takes username and password. This is a much more rigorous forgot password workflow. And you can take a look at the OWASP forgot password cheat sheet. It goes into this in detail. Also, don't forget to re-authenticate. So after a user logs in, where should we force re-authentication? Significant anomalous transactions, or if you're trying to change your email address, an admin feature, big financial transfers, those boundaries are really good to force re-authentication, because even if the session gets hijacked, you still stop the user in front of ultra-sensitive operation. Consider that as well. So, and this is a big topic. We have a lot of different cheat sheets on this. Authentication, password storage, forgot password, session management. So this is a big topic beyond that little blurb. I highly recommend you take a look at the Application Security Verification Standard. Because right now, who here writes code? Who here builds applications? Who's a developer? Do your managers want you to write secure code? Do they tell you specifically how to do it, or do they just say, write secure apps? Or do they tell you prescriptively what they mean by that?
I actually tell them.
Oh, you tell them. Okay. So I'm just saying, don't make it, so it should not just be in your brain. It should be codified in a list of clear requirements. And the place you start is the Application Security Verification Standard. There's a list of application or authentication and access and session management requirements. That's a good baseline for you to turn security into this hope and wish into a codified list of requirements. That's how you talk to developers, through requirements and clear guidelines of what you want them to build. So, number 6, data protection and privacy. All right, take a moment, take a moment. Break time. How you doing? You doing good? Good, cool. We'll break. We'll get this. We got 5 more. We can do this. Data protection and privacy, let's do it. So HTTPS is a good place to start. You want to do encryption in transit. This protocol's been radically broken for years. And recently, all the pieces that are broken around it have been patched well if you want to implement it. So a good place to go is the OWASP Transport Layer Protection Cheat Sheet. I'm hesitant to even mention a vendor here, but Ivan Ristic wrote SSL Labs. It's a free service, not open source, but a free service. It's become the default way to measure your website's TLS configuration. His research is way beyond everyone else. It's a free product. It'll publicly scan your website and ethically just verify if your SSL configuration is done correctly. Awesome stuff. As a developer, certificate authorities can send you a fake, if I'm man in the middle and I have access to a CA certificate, a private CA certificate, you might be surprised, but CAs aren't always trustworthy. Some CAs have tried to spy on their populace, and some CAs have actually sold their CA private certificate to private companies. Can you believe that, Tim? Doesn't that shock you? No, it doesn't. No, they all do it. They're all believe it. So let's not say that. Certificate pinning, especially a priori pinning, you take the actual public certificate from the server and out of band, hard-code it in the client. You have IETF pinning headers for a browser, or you can just hard-code it in the mobile app. So when you do the SSL connection or TLS connection, if that fetched public certificate isn't an exact match, then you just cancel the whole connection. This one's attacked really, like groups who have tried to do this is like the Turkish government, Turk Trust, and like the French cybersecurity agency. We've caught them in Chrome issuing fake Google certificates that were signed by a real authority. Let me ask you a question. Let me ask you, say Stu, why would an authority issue a fake certificate that was really signed by a real authority? Just an honest typo, right?
Yeah.
What are they trying to do?
Man in the middle.
Yeah, but why would a certificate authority do that To their users, though.
Spy on them.
Well, they're spying on them. There we go, exactly. So HSTS, this is a standard that when someone makes an initial SSL connection to you or TLS connection, you can respond by saying strict transport security, and for that many seconds, the browser is forced to always use HTTPS, so no one can even downgrade you. The browser makes that change. Forward secrecy. Forward secrecy says that I'm going to make sure to use a modern algorithm in ephemeral cipher suite. Doesn't that sound cool? Ephemeral cipher suite. That sounds cool. The benefit of this cipher suite is that the private key on your server has nothing to do with the temporary key established for encryption in the symmetric part of HTTPS. So even if I record all your traffic for years and brute force your key, it doesn't help me actually decrypt the SSL connection because those keys are ephemeral. But actually the real encryption, they're temporary. So boom, that's what forward secrecy algorithms do. Certificate creation transparency, I'm going to skip those just to make up some time. Again, strict transport security, response header over SSL, forces the browser to stay at an HTTPS. Now, you want to get really cool? Now, I don't have to talk about the slide. This is like super cool slide. You want me to talk about this or just skip it? Oh, you want the super cool stuff. Okay. What's the problem with strict transport security? When the user first opens their browser, they type an HTTP to yoursupersite.com, and your site redirects them to HTTPS. This is a common workflow. What is wrong with that workflow? Do you have a Boston sports hat on? Get the bleep out of my class. No, I'm just kidding. Patriots are all cheating bleepers. That's not a good way to say hello, is it? I'm just kidding. I'm from New York, you know, we buy our team, so. Okay, peace. So you up, you ready?
Okay.
So the first connection is HTTP. Your server sends response to say redirect. And then now we're SSL. What's wrong with that?
Takes a long time.
But what's the first connection? HTTP. And if I'm an observer on that network and I see your first hop is HTTP, guess what? It's too late. How can we make sure that even that first hop is never going to be HTTP? That's real security. So you can go to AppSec. This is the Chromium project. Once you're already delivering strict transport security headers of 18 weeks or more, you can then go request that your website be hard-coded into Chromium. Chrome and Firefox both pick this up. So when you have this all set up and Adam Barth, who runs Chromium, finally decides to accept your site, you become hard-coded into Chrome. When people download Chrome and hit your super site over HTTP, even before it's ever talked to that site, the browser flips it on the first request, so an HTTP connection is never made. If you really care about transport security, this is what you should be doing. Only about 1,000 sites do this right now, but there's an open API to let you do this to Chrome. It's picked up in Firefox and Chromium. We mentioned certificate pinning already, and we have even experimental IETF headers that Chrome and Firefox supports to pin through the browser. And finally, browser error messages when pinning is detected to be in play and the certificate's invalid, they say this, and they alert Chrome that this is happening and which authority did it. Your connection's not private. Attackers might be trying to steal your information from Google, for example, passwords, messages, or credit cards. So that's a really reasonable browser message. And so perfect forward secrecy, again, these are ephemeral cipher suites that will make sure that even when the private key is stolen, it's not going to compromise the encryption of the connection. So that's transport security. Cassio and myself are talking about this in depth tomorrow afternoon if you're really into HTTPS. What about stored data? How do you encrypt data in storage? What main algorithm do we use for cryptographic storage these days? AES. That's the main algorithm to use for cryptographic storage. And guess what? When you say encrypt in AES in Java, it defaults to ECB mode, which is basically plain text. It's a nonsensical method. We really want to use the gloss counter mode, GCM. You get integrity and encryption. But for enterprise support, we're probably stuck in CBC if we want wide enterprise and wide language report. And don't forget to have a unique initialization vector for every single message. Get your padding right. You probably want to do key storage and management right and isolate the crypto to a separate process. That mostly gives you confidentiality. You got to HMAC your ciphertext for integrity, derive integrity and confidentiality keys from the same match key with labeling. Don't forget to generate a good match key from a good random source. And good luck with that. You're not going to get it right for the most part. Some of the best teams in the world using modern languages trying to get crypto right, they mess it up. So don't try to do it. The best project out there is Google Keysar, Python, Java, and C++ with hooks to any language. This project is so awesome that Google in the last week or so is trying to rip the project away from everyone. They're saying, hey, there's not enough people who signed the ULA, so we're going to drop this project soon. And all of us who were watching Keysar immediately set up a GitHub fork, ripped copies of it. People are putting money in to get lawyers to stop Google. And I don't know why they're doing it. So if it's morning, I think they're just trying to finish some legal issues. If it's evening and I'm, and have 2 glasses of wine, I think it's a great conspiracy theory because it's the only really good applied crypto library besides NaCl. But this is a great way to just say, once it's set up, not that hard, encrypt plain text and get ciphertext. All the key management is obscured from the developer. So if you're a developer messing with keys in a normal web app, you're probably doing something wrong. I take with respect. Use a tool like this that does a lot of that mess for you. So, data protection. Number 7, we got this. Error handling, logging, intrusion detection.
Hey, Jim,
yes?
sorry, can we go back to the previous point? In enterprise environments, we very frequently run into situations with this where we start using libraries, like Isapi is a good example, and then they go away, or nobody maintains them. Or how does all of that, you think, works out here?
And I'm going to can I pick on you a little bit, Ed? I'm not trying to be disrespectful. Get Symantec to help fund some of these key projects. Shake some money up, baby. Come on.
Okay.
Number 1.
That's the answer.
So well, this is my opinion about Isapi. I believe, and I'm a part of this as well. It was sold under false pretenses. We told the world Isapi was ready to go. BS. That was an alpha project. It never got beyond alpha, and the core contributors started working on something else. We have so many critical bugs in it, and I've been waging a war against Isapi, not to be a jerk, but to stop people from using it because it's not ready for prime time unless you're willing to fork it and fix it and maintain it. And so,
Well, so not to pick on Isapi, right? But a general kind of, in enterprise environments, we have to go through a process. This is open source.
Mm-hmm.
We have to make sure it's a maintained project, and all of that, right? So once we start using it, it's a bit more of a challenge, right?
I agree with you.
Yeah.
But the 2 steps are, number 1, when you really pick a product that you want to use from the open source world, go through a really extensive vetting process. I know some big companies who early on went through an Isapi vetting process, and they're like, there's some childish mistakes in here that affect security. And those who did mature reviews picked it up right away. Those who blindly trusted us and blindly grabbed Isapi, they're the ones who got bit, right? So do your vetting process, number 1, and if you're a big enough company, if you're going to really depend upon an open source project, then contribute or fund it in some way. Look, everybody and their mother was using OpenSSL, but nobody was funding it, hence we all got whacked by Heartbleed, which is just a basic buffer overflow. We should have caught that. That should never have gotten into the code base if we were even doing basic assurance. Now that we got whacked hard by Heartbleed, and the behind the scenes effect from Heartbleed is like nation state, spy novel type stuff all the way. We would, and now Google and Microsoft, not Microsoft, but many other companies have given OpenSSL and millions of dollars to finally do proper assurance. Don't wait for the open source project you depend upon to have to break. Help fund them and responsibly contribute to make sure that they can do these things like advanced assurance process throughout the life cycle. That's my answer, right?
Sounds good.
And look, Jeff, the head of Isapi, who rented it, we've been at conflict over this. He doesn't agree with me that it's not production ready. And that's okay, it's a fair debate. I went to Jeff and said, hey Jeff, hope he's here. I'll put up $500, you match me, we'll put bounties out to fix some of these core problems. So I'm not just critiquing Isapi, I'm putting my money where my mouth is, willing to help fund it to make it better. So I feel a little more responsible. If I just critique it and pee on it and that's where I end, shame on me. But if I'm willing to invest in it, and put time into it, and put my money into it, then I think I feel a little more integrity critiquing it. And expand it up to your level. The same thing up to the Symantec level. Symantec, you're going to have a library and really depend upon it for the heart of your business and software, and help us make it good. And I know you have 50,000 layers of lawyers making that difficult, but hey, we're not giving the easy problems, right? We're giving the hard problems, Ed. Cool?
A lot of libraries out there, just saying.
Oh, I know. But
So I'm just saying, as
you're going to have to put
AppSec,
more effort into some than others, right?
as AppSec professionals, we often are in this situation, right? We need to advise some kind of libraries, but very often it happens we advise the ones that ultimately don't really work for those developers, right?
So I do my vetting process before I recommend these libraries. I'm either a participant in it, using it in production, or going through a really careful vetting process. For example, for access control, I really like what Apache Shiro does in terms of their model for permission-based access control, but it's so complex to use, I don't recommend it per se. I recommend the technique, but not the library itself. So I try to be careful in those recommendations. This is a hard problem. One more note, look at dependency check from Jeremy Long. This is a open source, free application you can throw against Java. Look at all your third-party libraries and let you know which ones have public reported vulnerabilities against it. So this is, again, this competes with multi-million-dollar solutions. It's free. So at the very least, you should do your due diligence and use these dependency checkers. Look at the commercial space too, whatever, and make sure you're doing that third-party verification when you are using open source libraries. All right, let's move on. Next, error handling, kind of boring. Logging, really boring. Logging is important, but really boring. Let's talk about intrusion detection. So a couple detection points to start with. When you have client and server-side input validation, like we see in .NET, if you ever see client-side validation subverted, then you should, if you have client and server-side validation in place, you should almost never see server-side validation errors, so when you do, it's a possible attack. Here's a key one though. Think of all the immutable fields in a web app, like a hidden field, or a checkbox, or a radio button. Imagine you have like a yes or no question. It's a radio button. That means you have two choices, yes or no. You can't free type into a radio button, right? You only make two selections. But if I use an intercepting proxy or a tamper data plugin, I can receive that radio button selection, capture it, and change it. So if you have a radio button where a normal user can only say yes or no, and you get a different value, what's happening? You're being attacked by intercepting proxy. And if I get my app really coded correctly, and I see one immutable field modified, I lock the account. You're out. Done. If I get it wrong, I lock the account inappropriately. Be careful. Apps like Facebook use this technique, and it really makes pen testing Facebook much more difficult. You can no longer tweak immutable fields to be an injection or other attack. Honeypots, this is just a fun one. So in robots.txt, that robots.txt goes in the root of your web server. It tells search engines what they can and cannot search. So I can make a call in robots.txt that says, please do not index admin supersecret.login. Who here's a hacker? Who here's a professional penetration tester? Who's a pen tester here? So dude, just go work with me on this. I need you to be on stage and chilling for me. You go into an app and you want to be stealthy. You didn't hit the app. You hit robots.txt first. And you see like /admin/secretlogin.jsp as a do not index. What's your next request? You see a login page. What do you do next? Boom. So what my app does is super secret login or secret login is not linkable anywhere in the app. It's only identified in the robots.txt as do not search. And once they get to that feature, it's not a real feature any user would see. So you don't mind if you hit the login page. Many evil search engines do that. Anyone who submits to the login page, I just randomly sleep 5 to 10 seconds, alert the admin team, and then you can say login failed. It doesn't actually log into anything. It's a honey token. It's luring a hacker because a secret login is like crack to a hacker. I gotta try it. They see the login page, super login, admin only, unauthorized users only. They can't help themselves. They're gonna throw Brutus at it or throw some kind of tool at it, try some common passwords, and the first, I got you right away. I had a 6-figure red team going off against my app. I didn't even know they hired these people. And Johannes Ulrich taught me this trick, so I put it in, it's an easy thing. This elite 6-figure red team, whose job was to actually hurt the app, they lasted 7 seconds before we caught them and stopped them because I had this in place. Consider it. Let's see if I can pull this off. So that's it for app layer intrusion detection. OWASP App Center is awesome sauce. This is from John Melton. Version 2 is about to go out. This is a way you can add detection points in your code to trap attack situations, not outside in the product, but deep in the app itself. Next, you want to leverage the security features of frameworks themselves when you can. Spring, Struts, Ruby on Rails. Modern frameworks more and more have controls built in. Use them. I'm not going to go into that in too much detail. And we're almost done here. Security requirements. This is like ASVS. Don't let a secure app be an idea in an expert's head. That's a good place to start. We want to codify it in clear requirements. Go to ASVS as a starting point. Don't end there. It's a starting point to define those requirements. And I'm going to skip this for now. Yeah, OWASP ASVS is what I want to point you to for that topic. And yes, security architecture and design, you should definitely do security architecture and design. La 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 la. Thank you so much. I appreciate you all being here. I'm mortified that I was late. Hope this was still of value to you in some way. If you want a copy of the deck, it'll be loaded into the OWASP Proactive Control project. Any questions before we finish up? Pardon me? I've done it in 10 minutes is my record for 10 minutes on Java security. So yes, yes, Richard.
Did you like Manico Beach?
No. I really want to be here.
We'll take you there another time. Don't worry.
Another time I'll go. I really wanted to be here. All of a sudden it's like, hey, we're here. We're down to a beach, and I'm like, all of a sudden my world went. But we made it. We did it. Go forth and encourage developers supportively, or go write secure code yourself. Enjoy the conference. Thank you so much, everyone. Aloha.
Oh, what's this one? The hacking one, yeah. Yes. Oh, yeah. Let's say.
I'm going to move myself. I was more too much.
When I present, I even if it's in the 400 people, I'm like, that wasn't right.
And you work with contracts?
No, I work with Sorry. It's actually right when we were the black and white button. Yeah.